We are going to go over an introduction to solving differential equations. This is by using an integrating factor. We are going to solve for this. Y prime is equal to t times y plus t cubed, and we are using the initial condition y of 0 is equal to 1. So, based upon this, we have our differential equation y prime is equal to ty plus t cubed. And in order for us to use the integrating factor, we need to move this ty to the left. So we have y prime minus ty is equal to t cubed. So for the integrating factor, I'm going to write this up here. Integrating factor. Let me just highlight it in here. Because of this negative ty right here, the integrating factor just takes the coefficient. So we are going to have this being e to the integral of negative 2t, just negative t, no 2, negative t dt. So based upon integration, this is going to be e to the power of negative t squared divided by 2. And we're going to multiply both sides of this differential equation now by e to the negative t squared over 2. So doing so is going to make e to the negative t squared divided by 2 times y prime minus e to the negative t squared over 2 ty is equal to e to the negative t squared over 2 times t cubed. Then we see here on the left side first, this particular part's right here. We could simplify that slightly, very slightly, because judging based upon the way that this looks, this left-hand side here looks like we have the product rule. When we take the derivative of a product, we would, of a particular product, we would get this particular answer. And that product is going to be written as the derivative with respect to t is going to be and I just realized this is not supposed to be a squared here, this is supposed to be a prime. The derivative with respect to t is going to be of e to the negative t squared over 2 times y. And that's going to be equal to t cubed times e to the negative t squared over 2. And we are going to now integrate both sides. The left-hand side will just cancel out and be left with e to the negative t squared over 2 times y. The right-hand side, however, is going to be a little more complex. So this is going to be equal to the integral of t cubed e to the negative t squared over 2, and we're doing this with respect to t. So for this, we would need to use integration by parts, and if we were to use one round of integration by parts on this, we are going to get e to the negative t squared over 2 times y is going to be equal to, so that first round of integration by parts is going to yield negative t squared times e to the negative t squared over 2 minus the integral of negative 2 t e to the negative t squared over 2 dt. And once again, because of that, we're going to have to take a second integral here, due to the way that the integration by parts works. Doing so, we are going to obtain, and let's see how I want to write this. Let us write it as, completing this now, we're going to get e to the negative t squared over 2 times y is going to be equal to, this would be negative t squared e to the negative t squared over 2 minus 2e to the negative t squared over 2, and we are going to have a plus c here at the end. And now, based upon this, we can multiply both sides of this. We could multiply both sides of this by the positive e to the t squared over 2. So the positive version of this negative exponent. So because of lack of space, I'm just going to write multiply both sides by e to the positive t squared over 2. Doing so is going to yield y is going to be equal to negative t squared minus 2 plus c times e to the t squared over 2 power. And that would be the general form of this differential equation. Since we have our initial condition here, that will be y of 0 is going to be equal to negative 0 squared minus 2 plus c times e to the 0 squared over 2 power. This is supposed to be equal to 1. So we have a 0 here. This makes 1. This just makes negative 2 plus c is equal to 1. Which means then that c is going to be equal to 3. So the specific differential equation is going to be y, and actually let me write it a bit more proper. Y of t is going to be equal to negative t squared minus 2 plus 3e to the t squared over 2 power as our complete differential equation. Thank you.